In this module, we shall learn about the Dornbusch exchange rate overshooting model. Some economists hold the view that volatility in exchange rate market is a result of speculators, information asymmetries and market imperfections. However, it was in the year 1976 when the economist Rüdiger Dornbusch published his paper titled Expectations and Exchange Rate Dynamics in the Journal of Political Economy that gave the birth to a new international macroeconomic theory to explain the dynamic of exchange rates while at the same time providing reasons to why such volatility in exchange rate is consistent when everyone in the economy follow rational expectations for the exchange rates. This model is now widely known as Dornbusch overshooting model. According to this model, in the short run, due to the assumption of sticky prices, when there is a change in monetary policy, there is an extreme volatility, nominal exchange rate going well beyond their long run level. This extreme volatility is explained by the term overshooting in Dornbusch overshooting model. Sometimes this model is also considered as dynamic version of Mundell-Fleming model. This model is a mixture of sticky price assumption of the short run Mundell-Fleming model and the flexible exchange rates and the rational expectation from the long run models in which prices vary in the long run. It is also based on the observation that the adjustment in the foreign currency market is very rapid while the adjustment in the product market is sluggish. In this module, we studied the basic assumption of this model, mathematical derivation of this model and how to represent the changes in monetary policy on exchange rates graphically.
After studying this module, you shall be able to know the concept of Dornbusch overshooting model, mathematically derive the model, understand its implications for a small open economy in the short run, learn how to depict the model graphically, identify the effects of a change in monetary policy on the exchange rates. Dornbusch exchange rate overshooting model is a model that assumes that the economy is operating in the short run and it rests on some basic assumptions. First, small open economy. Second, perfect capital mobility. Third, price of imports given. Fourth, output is given in an economy. 5. Sticky prices and flexible exchange rate. 6. Goods and money market in equilibrium. 7. Perfect foresight. 8. Economic agents are risk neutral. First, we have small open economy. The country's foreign capital market is small in comparison to the world capital market and hence it faces a given interest rate which is equalized to the world interest rate. Secondly, perfect capital mobility. There is perfect mobility of capital in and out of the economy which ensures that the yield on the domestic securities is equalized to the yield on the foreign securities. Thus, due to this assumption, the uncovered interest parity condition holds and assets denominated in domestic currency and assets denominated in foreign currency are considered as perfect substitutes. Next, we assume that the prices of imports are given. Since the economy is a small open economy, in the domestic market, the world prices of imports are given. Domestic output is not a perfect substitute of imports. As a result, the prices of domestic goods, both absolute prices and relative prices in terms of imports, are determined by the aggregate demand of domestic goods. An implication of this assumption is related to the real exchange rates, which are given by capital R is equals to capital E P star by P, where capital E is equals to nominal exchange rates, P star is the price of imports which is given, P is the domestic price level. Taking the natural log on both the sides, we get log capital R is equals to log capital E plus log P star minus log P. Since P star is fixed, normalizing it to 1, we get log P star is equals to log 1 is equals to 0. Thus, the above equation becomes log capital R is equals to log capital E minus log P. Moving on to the next assumption, we have the output is given in the economy. The model assumes that the full employment level of output or the natural output in the economy is given to be some constant, say. Further, we have sticky prices and flexible exchange rates. The goods prices are sticky in the short run but vary in the long run. This implies that aggregate supply is horizontal in the short run but may be assumed to be vertical in the long run. However, prices in the model are determined by the flexible exchange rates regime. This assumption ensures that purchasing power parity condition holds. All the variables are assumed to be in natural logarithmic terms, except the rate of interest and percentage change variables. This simplifies the mathematical derivation of the model and the representation of the effect of monetary policy change on the exchange rates. Next is the assumption of perfect foresight. Agents in this model are assumed to have perfect foresight when forecasting exchange rates. Perfect foresight is a special case of rational expectation hypothesis, also called deterministic expectations. Thus, according to this equation, the expected value of the depreciation of the exchange rate will be equal to the actual depreciation of the exchange rate. There is no random error component. Further, we have that both goods market and money market are in equilibrium. The economic agents are risk neutral. Let us now move on to the mathematical derivation of Dornbusch overshooting model requires equations representing equilibrium in capital market, money market and goods market. It also requires the Phillips curve equation. These four equations represent the structure of Dornbusch overshooting model. However, the full model requires two more equations which represent simultaneous solutions to the above four equations. Thus, in all, there are 6 equations to this model. Capital market. Due to the assumption of perfect capital mobility and flexible exchange rates, interest parity condition will always hold. This ensures that capital market will always be in equilibrium. Thus, the equation for interest parity or capital market equilibrium is as follows. I is equals to I star plus capital E bracket E dot bracket close, where I is equals to domestic rate of interest, I star is equals to world rate of interest, E is equals to domestic price of foreign currency or the exchange rate, E dot is equals to change in the domestic price of foreign currency or the depreciation of the exchange rates. Due to the assumption of perfect foresight, the above equation will become I is equals to I star plus E dot. Moving on to the money market is assumed to be equilibrium when money demand is equals to money supply. Demand for real money balances is a function of domestic interest rates and real income. Nominal money supply is assumed to be fixed by the central bank. Note that in the ISLM framework, LM curve represents the money market equilibrium. Thus, we have the following LM curve equation. Real money supply is equals to real money demand. M by P is equals to F bracket I comma capital Y bracket close, where M is equals to nominal money supply, P is equals to domestic price level, capital Y is equals to real domestic output or income. Money demand is negatively related to domestic interest rates and positively related to real income. Assuming money demand takes a Cobb-Douglas functional form, we have M by P is equals to y to the power beta e to the power minus alpha I. Interest rates I enters in the exponential form. Taking the above equation in natural log terms, we get small m minus small p is equals to minus alpha I plus beta small y, where small m is equals to log of nominal money supply, small p is the log of price level, small y is the log of output or income, alpha is the semi-elasticity of money demand with respect to interest rate. Note that interest rate is not in long terms. Beta is the elasticity of money demand with respect to real income. Goods market. IS curve represents the goods market equilibrium. In the goods market, demand for domestic goods depends on the relative price of domestic goods with respect to foreign goods, interest rates, and real income. Thus, we have the following equation for IS curve. Capital Y is equals to G bracket capital R comma I bracket close, where capital R is the real exchange rate or the relative price of domestic goods. As mentioned in equation 3 above, in natural log terms, we have log capital R is equals to log capital E minus log capital P, or we writing in simpler terms, small r is equals to small e minus small p. Giving functional form to the above IS curve equation in natural log terms and using equation 9, we get the following equation for goods market equilibrium. Small y is equals to small y bracket small e minus small p bracket close, where small y is the functional form relating the responsive of demand for domestic goods to relative prices. Small y is greater than 0 implies that if exchange rates depreciates, domestic goods become relatively cheaper in comparison to the foreign goods and hence output or demand will increase. The domestic currency depreciates whenever E minus P increases. The fourth equation in the Dornbusch overshooting model is the Phillips curve equation. Phillips curve shows the inverse relationship between inflation and unemployment within the economy. This curve can be molded to show positive relationship between inflation and output. If output is above the full employment level or the natural output, then there is inflation in the economy. Thus, following is the Phillips curve equation in natural log terms. P dot is equals to pi bracket log capital Y minus log capital Y bar bracket close, where P star is equals to percentage change in the price level, capital Y is the output produced in the economy, Y bar is equals to full employment level of output or natural output. Pi is equals to adjustment factor gives the speed with which prices adjust to the difference in the output level. Since prices increase with excess demand and are sluggish or slow to adjust, so 0 is less than pi is less than infinity. Thus, the above equation shows that the prices are proportional to the excess demand in the goods market. Next, we have the structure of the Dornbusch overshooting exchange rate. The structure of Dornbusch overshooting exchange rate model is given by the four equations A, B, C and D. That is, I is equals to I star plus E dot, M minus P is equals to minus alpha I plus beta Y is equals to capital Y bracket E minus P bracket close, P star is equals to pi bracket log capital Y minus log capital Y bar bracket close. Solving the above four equations for E dot and P dot in terms of E and P will give us two non-homogeneous equations. In equation D, log capital Y bar is equals to 0. We have assumed earlier that full employment output is given in the economy. It can be normalized to 1 to give us its log value of 0. Thus, equation D simply becomes P dot is equals to pi y. Substituting value of y from equation C into the above equation, we get P dot is equals to pi y bracket E minus P bracket close. This is equation E. Now substituting value of y from equation C and value of I from equation A into equation B, we get the following equation of E dot. E dot is equals to beta y by alpha into E plus 1 minus beta y by alpha into P minus 1 upon alpha into M minus I star. This is given as equation F. Equations E and F are the two non-homogeneous equations which provide solution to the Dornbusch overshooting model in terms of E and P. Solving these two equations provides two roots which are equal in magnitude but opposite in signs. Positive root is an unstable root while negative root is a stable root. It is difficult to solve this equation system of equations here to get a steady state solution, as it requires matrix formulation. Interested readers can refer to Hegda and Plog and Dornbusch. Let us now understand the model graphically. In the figure, phase plane diagram is shown. Phase plane diagram shows steady state solution to the dynamic model. Price is represented on the x-axis and exchange rate on the y-axis. Along the two axes, equation E and F showing the change in the variable price P and exchange rates E are plotted. To plot these two equations, we are equated to 0 or E dot is equals to 0 and P dot is equals to 0. Consider equation F first. We need to plot E dot is equals to 0 line. Nominal money supply M is given by the central bank and world interest rate I star is also given for an economy. These two are shift parameters. The figures show that the E dot is equals to 0 line. Panel A shows upward sloping line while panel B shows downward sloping line. Arrows drawn in figure show how the system moves along E dot is equals to 0 line. If the economy situation were to be above this line, it means that for a given price level, exchange rate would increase or that the domestic currency would depreciate, making the domestic goods cheaper in comparison to the foreign goods. Demand and hence output would increase. A higher output means a higher income, which would trigger in a higher demand for money, creating disequilibrium in the money market. Excess money demand over money supply would raise the domestic interest rate relative to the world interest rate, or I is greater than I star. To maintain interest parity condition and due to perfect capital mobility, exchange rates would depreciate further or E dot is greater than 0. Thus, at any point above E dot is equals to 0 line, the system of economy will move up. Similarly, if the economy is at any point below the line E dot is equals to 0 line, it will move downwards. The arrows in the diagram show the motion of the economy. Analysis will remain the same whether one considers upward sloping or downward sloping E dot is equals to 0 line. Note that the system of becoming unstable because of interest parity condition. Exchange rate movements are magnified rather than getting lowered. Hence, the movement is away from the E dot is equals to 0 line if the economy is not on that line. Here, it should be noted that E dot is equals to 0 represents an equilibrium situation. Now coming to equation E, which is P dot is equals to pi y bracket E minus P, Putting P dot is equals to 0, we get E is equals to P. Thus, P dot is equals to 0 is straight 45-degree line. The figure shows the motion of the economy along the P dot is equals to 0 line. Along P dot is equals to 0 line, output is equals to full employment level. For the same level of exchange rate, if the economy is on any point to the left of P dot is equals to 0 line, it means that output is greater than the full employment level and hence prices will rise. Similarly, any point to the right of P dot is equals to 0 line implies the output is less than full employment level and hence prices will fall. Thus, if the economy is away from P dot is equals to 0 line, it will converge towards it. Combining the earlier two figures into one graph, or in other words plotting equations E and F in one graph, will give us the following phase plane diagram. Equilibrium is attained at point E. Arrows show how the economy will move if it is away from the equilibrium. As mentioned in the previous section, there are two routes to the system. The unstable route will take the economy away from the equilibrium point E. This route will come up if the economy lands up in section 1 or section 3 of the cross shown in the figure. The stable route will take the economy towards the equilibrium. This route will come up if the economy lands up in section 2 or section 4 of the cross shown in the figure. Thus, one route is a convergent route and the other is a divergent route. Saddle path is a curve which shows the combinations of all initial conditions from which an economy attains equilibrium. This is the only convergent path which will take the economy to the equilibrium point E. In the following figure, SS line is saddle path. Next, we have the monetary policy change and overshooting. The effect of a change in monetary policy on the exchange rates is different under this model depending upon whether we are considering short-run or long-run analysis. Dornbusch says that due to the monetary policy change, exchange rates in the short run will overshoot their long-run values. We provide a brief analysis of the effects of monetary policy change in the long run. We will then discuss how exchange rates overshoot in the short run. Through the analysis, we assume that there is an unanticipated permanent increase in money supply. The analysis for a reduction in money supply can be understood in a similar manner. In the long run, output is at its full employment level and prices are flexible. An increase in money supply leads to an increase in aggregate demand. Since output is fixed at its maximum potential, it will cause an equiproportional increase in the price level, making the real money supply same as before. The exchange rate or E will increase, making real exchange rate same. Thus, there will be no effect on the real variables, real money supply, real exchange rates, output, and real income, and the domestic interest rates. In the short run, prices are sluggish to adjust. If there is an unanticipated permanent increase in money supply, exchange will become highly volatile and will depreciate by a huge amount. An unexpected permanent increase in nominal supply of money, with prices being sticky in the short run, implies an increase in the real money supply in the short run. This would cause a decrease in the rate of interest to restore the equilibrium in the money market in the short run, and as a result, the domestic rate of interest will fall below and world rate of interest. Consequently, the return on domestic assets will become less than that on foreign assets. In the market for assets, this will be a state of disequilibrium in the short run. How will equilibrium be restored, especially in the long run? In the long run, the level of output and demand for it must be at the full employment level of output. The rate of interest, too, must come back to its original level. The only change in the domestic economy will be that the price level would have increased by the same proportion as the permanent increase in the nominal money supply. With the price level increasing in the same proportion as the nominal money supply, the level of aggregate demand would be at the full employment level if and only if the nominal exchange rate E were to increase by the same proportion as the price level, given that the rate of interest is at its original level. With the rate of interest returning to its original level, which is the same as the world rate of interest, there would be a restoration of long-run equilibrium in all markets if the nominal rate of exchange E were to indeed increase by the same proportion by the price level. This is known to the economic agents. Hence, once it has been realized that the nominal money supply has been increased by a certain given level, they would be able to calculate correctly the proportional increase in nominal rate of exchange. However, the nominal rate of exchange does not increase directly to that level in the short run, but increases by a greater amount. This is because in the short run, the price level does not increase, and therefore the real money supply and the domestic rate of interest remain above and below their long run levels respectively. Under these circumstances, international capital movements would be in equilibrium only if the rate of return on domestic assets were to be the same as the return on foreign assets. However, the domestic rate of interest and hence the return on domestic assets is lesser than the world rate of return, which is equal to the world rate of interest. The only way in which the rate of return on domestic assets can equal the world rate of interest in the short run is for there to be an expected appreciation to an extent equal to the difference between the world rate of interest and the domestic rate of interest. The nominal rate of exchange can only fall to its expected and higher level only if in the short run it rises to a greater extent than its long run equilibrium level. Remember that the rate of exchange adjusts much more rapidly than the price level. Hence, the rate of exchange increases to its a much higher level even though and indeed because the price level has not increased. This is what constitutes the phenomenon of overshooting. This is a heuristic explanation which Dornbusch explained by means of a rigorous model.
The figure explains the effect of an increase in money supply in short run through the phase plane diagram. In the figure, price is shown on the x-axis and exchange rate is shown on the y-axis. The economy is at equilibrium at point capital E naught where P dot is equals to 0 and E dot is equals to 0. Lines intersect. S1 is the saddle path. Now suppose there is an increase in money supply. Money supply appears as a shift variable in E dot is equals to 0 line. With an increase in money supply, exchange rate will depreciate. Thus, E dot is equals to 0 line shifts. It shifts from E dot naught is equals to 0 to E dot 1 is equals to 0. As a result, the solution of the system of equations E and F will change, leading to a new saddle path of S2. The new equilibrium should have been at point E1. However, prices are slow to adjust with the change in money supply, but exchange rates are not. The economy does not move to point E1 immediately. Thus, initially economy will move to point E2 where E dot 1 is equals to 0 line and S2 intersect. Because exchange rates are flexible, at point E2 they have fully adjusted. Basically, the exchange rates have depreciated by a large amount than it should have been if the prices were not sluggish. The sluggishness of prices has been counterbalanced by over-movement in exchange rates. This over-movement is what Dornbusch calls overshooting of exchange rates. The new equilibrium exchange rates should be E1, but it overshoots this value and settle down at E2. It is when the price levels start adjusting that the economy will reach its new equilibrium long run at point E1. Thus, in the short run, an increase in money supply moves the economy from point E0 to E2. In the long run, due to adjustment of price level, the economy will move from E2 to E1.
To visualize the time path of different variables, we have the figures shown. At time t0, money supply increases from m0 to m1. In the long run, there is an equal increase in the exchange rates and the price level. However, in the short run, at time t0, exchange rates jump to E2. Since prices are slow to adjust, they increase at a slower pace to their long-run value of P1. As a result, exchange rates get back to their long-run level of E1 when prices also get fully adjusted. If initially output was at its full employment level, an increase in money supply will increase output beyond its full employment level. It is when prices start adjusting, output will return back to its long run level as shown in the figure.
The module can be summarized in the following points. Dornbusch exchange rates overshooting model shows why the exchange rates are volatile in short run even if there are flexible exchange rates and agents have rational expectations. The model combines the Keynesian short-run framework with the monetarist long-run analysis to link the theory with the real world. The major assumptions of the model are sticky prices, perfect capital mobility, flexible exchange rates, and perfect foresight of the agents. Mathematically, 6 equations define the structure of this model. 4 equations represents the equilibrium of capital market, money market and goods market and the Phillips curve respectively. The 2 equations, that is P is equals to 0 and E is equals to 0, shows the dynamic that leads the economy to the equilibrium. An increase in the money supply in the short run depreciates the domestic currency well above its long run level, causing overshooting. In the long run, an increase in money supply has no effect on the real variables. Only nominal variables changes.